Assalamualaikum and welcome to Cambridge Chemistry channel. Be sure to like the video and subscribe. It really helps the channel to grow. Today I will discuss some MCQs from gaseous state of matter. So these are the most tricky MCQs which you should understand in detail. In this way you can solve other MCQs like these MCQs, because mostly in this topic the MCQs are just like this, which I will want to discuss with you. So first question: which gas is likely to deviate most from ideal gas behavior? So the gases, you know that we have two types of molecules, polar and non-polar molecules. Polar and non-polar. So for this question, first identify that which is, because polar molecules, and because polar molecules deviate most. Deviate most. And in this question, HCl is polar, helium is non-polar, CH4 is non-polar, and nitrogen is non-polar. Second, first identify the polar and non-polar molecules, and we know that polar molecules deviate most. Second is the strength of IMF, intermolecular forces, which have most intermolecular forces, most stronger IMF deviate most. And vice versa. So these three gases are non-polar. Obviously HCl is a polar, so HCl has permanent dipole forces, and these non-polar molecules has induced dipole, induced ID forces, which ID forces are less stronger than the PD forces. So this is very simple, that in this question, which gas is likely to deviate most from ideal behavior? Nitrogen is non-polar, CH4 is non-polar, helium is non-polar. So the gas which is likely to deviate most is the HCl, because it has stronger permanent dipole forces. So that's why HCl is deviate most. There is another question. Next question is, the gases represented are ammonia, hydrogen and nitrogen. So as I have discussed earlier in above question, that the polar molecule which exist in gaseous state deviate most, while non-polar deviate less. So from this graph, these graph questions are very important, and commonly examiner asks you to ask in the exam papers. So let's discuss this question. The gases represented are ammonia, hydrogen and nitrogen. What are the identities of the gases X, Y and Z? So this is the deviation. This is the deviation from the ideal behavior, and This is deviation from the ideal gas. So this Y shows positive deviation while Z shows negative deviation. Y shows positive deviation while Z shows negative deviation, and so this is the most deviate from this ideal behavior. And you know that the in above gases ammonia, hydrogen and nitrogen. Ammonia is polar molecule with strong IMF force, that is hydrogen bonding. H bond is present in ammonia molecules, so hydrogen bonding is more stronger than the IDID and then the permanent dipole forces. So ammonia shows most deviation. So for hydrogen and nitrogen, look at the hydrogen and nitrogen. For non-polar, when we want to compare non-polar gases like hydrogen and nitrogen, just look at the number of electrons present in hydrogen and nitrogen. Hydrogen has 2 electrons. Number of electrons and MR. First MR is in hydrogen is 2 and in nitrogen 28. So nitrogen has higher MR. So higher MR shows that the most deviation, nitrogen deviate more than the hydrogen. So hydrogen can determine hydrogen H2 might be hydrogen because less MR, and ammonia nitrogen is X, and the gas which is deviate most is the ammonia NH3 due to it is a polar molecule as well as strong hydrogen bond is present in ammonia, so it deviate most. So the option is X is nitrogen, Y is hydrogen, and Z is ammonia molecule. So D option is correct. Next question is use of the data booklet is relevant to this question. The gas loss can be summarized in the ideal gas equation. PV is equal to nRT. 0.96 gram of oxygen gas is contained in a glass vessel of volume 7,000 centimeter cube at a temperature of 30 degrees centigrade. What is the pressure in the vessel? Now we know that PV is equal to nRT by modifying this equation to calculate the pressure. Question number 3. To modify this for PV is equal to nRT, and if we want to calculate P, so the P is equal to nRT over V. And we know for P, we know that PV is equal to nRT. For PV is equal to nRT, pressure is in meter cube, pressure in Pascal, and volume in meter cube. R is 8.31 and temperature in Kelvin. R is gas constant, temperature in Kelvin. So 700 centimeter cube, to convert this into meter cube, divided 10 raised to 6. So temperature 30 degrees centigrade, to convert it into Kelvin, 30 plus 273. This is equal to Kelvin, which is 3 and 03 Kelvin, and this is mass. We know that n is equal to m over mass over mr, and this equation now can be rewrite. P is equal to mass over mr RT. Now, what is the pressure in the vessel? So use this data booklet. We can calculate this question like P is equal to 0.96 gram, 0.96 gram into P is equal to nRT, so m over mr into volume RT. 0.96 into 8.31 into 303 divided by mr of oxygen gas is 32 into 7000 into 10 raised to minus 6. So by applying this, we just calculate, and the answer is 10.8 kilopascal. So because kilopascal, so after calculating, because we are using over here Pascal, so after calculating this equation, this it will be converted into again kilopascal by multiplying into 10 raised to 6, which would behave the least like an ideal gas at room temperature. At room temperature, you know that the conditions at room temperature. Question number 4. At room temperature, there is high temperature, and these are two postulates which are at room temperature: high temperature and low pressure for ideal gases, where volume is negligible and there is no intermolecular forces between, there is no significant forces between the molecule of gas, and collision is elastic. So this is at RTP. These are the conditions. at room temperature and pressure. Nitrogen, and we have discussed earlier that polar gas deviate most, and which would behave the least like an ideal gas. So nitrogen is non-polar, hydrogen is non-polar, helium is non-polar, carbon dioxide is polar. So carbon dioxide and more electrons, more mr is 44, helium is we know that helium is 4, hydrogen is 2, 28. So in addition to the higher mr, there is significant forces, IDID, more IDID forces in carbon dioxide than all these gases. So carbon dioxide like an ideal gas at room temperature, least like an ideal gas, not like an ideal gas, least like an ideal gas. Question number 5, the general gas equation can be used to. Question number 5, the general gas equation can be used to calculate the mr value of gas. For a sample of gas of mass milligram, which expression a gas of mass gram, which expression will give the value of mr. So we know that PV is equal to nRT, and PV is equal to, this is number of moles, PV is equal to mass over mRT. And now mr is equal to mass m r t over PV. So here mr is equal to mpv over rt is incorrect. mr is equal to pv, rt is also incorrect. mrt over pv is correct. So this is correct option. Flask X contain 1 dm cube of helium at 2 kilopascal pressure, and flask Y contain 2 dm cube of neon at 1 kilopascal pressure. If the flasks are connected at constant temperature, what is the final pressure? So question number 6 is, so pressure and volume are changing. When the pressure and volume are changing, there is no need to change the units. Like 2 kilopascal we are using like 2 kilopascal, 1 dm cube we are using, just like no need to conversion. If there is pressure, volume are changing. So in this question, flask X connected with flask Y contain, for example, this is flask X and this is connected with this is flask and connected with flask Y. This is X, this is Y. Flask X contain 1 dm cube. Over here volume is, so let's say its volume 1 is 1 dm cube. And here in flask X contains helium. At 2 kilopascal pressure is 2 kilopascal, and Y contain neon gas. Over here neon gas, and in this flask volume is V2 is equal to 2 dm cube, and pressure is 1 kilo Pascal, while temperature remain constant. Temperature is constant, and when temperature constant we are using P1, this expression P1 V1 is equal to P2 V2. So these are the gases, and we know that when these two flasks are connected, so volume there is P1, so sum of both pressure and volume P1 V1 plus P2 V2 is equal to P final and V final. So expression is just like this. We know pressure in flask X2 into 1 plus P2 is 1 into 2 is equal to PF final volume, and B is equal to 1. And we know that the total volume of the final volume of in these two flasks here is 1 volume and there is 2 volume. So the final pressure will be 3, and this is 2 1 2 plus 2 is equal to PF into 3. So this is 4 is equal to PF over 3. So 4 over 3 is equal to 1 kilo Pascal. So the answer is A. So next question is which expression gives the pressure exerted by 1.6 into 10 raised per 2 minus 3? Pressure exerted by mole, this is mole, number of moles N, and this is nitrogen in container of volume 3 dm cube. 3 dm cube mean 3 into divided by 1000, or in other words this is equal to 3 into 10 raised per 2 minus 3. Which expression gives the pressure exerted by the, we know that pressure is PV is equal to nRT, while pressure is equal to nRT over V, and P is equal to pressure is equal to gives the pressure expression N is equal to 1.6 into 10 raised per 2 minus 3 multiplied by R 8.31, and temperature is 273 degrees centigrade. If 273, then it is equal to 273 plus 273 divided by volume is equal to 3 into 10 raised per 2 minus 3. So look at the expressions. A is incorrect because volume is minus 6, 8.3, and this is degree centigrade. So this is incorrect. 1.6 into 10 raised by 2 minus 3, 8.3. This is correct, but volume is 3 into 10 raised by 2 minus 6. This is again incorrect. 1.6 into 10 raised by 2 minus 3 into 8.31 is correct. This is incorrect. This is because temperature is mentioned in degree centigrade. 1.6 into 10 raised by 2 minus 3, 8 into 8.31 into 273 plus 273. So this is in Kelvin. Temperature is in Kelvin. Volume is correctly shown volume. This is 3 into 10 raised by 2 minus 3. So D option is correct option. Next question is, in which change would only van der Waals forces have to be overcome? C2H5OH liquid changes into gaseous state. Solid changes into melting of ice. Solid changes into evaporation into gaseous state. Solid changes into liquid. Carbon dioxide. So question number 8, in which change would only van der Waals forces have to be overcome? Evaporation of ethanol, there is a hydrogen bonding. Melting of ice, also hydrogen bonding involved. Melting of solid, carbon dioxide is the van der Waals forces. Melting of solid, it has one of the, so this is C option is correct. Solidification of butane, in which change would only van der Waals forces have to be overcome? So this is solidification of butane, evaporation of ethanol, liquid to gas, temperature is involved. Melting of ice, also endothermic reaction when we provide, and this is similarly liquid to solid, this is condensation. So this is only melting of solid, carbon dioxide is the van der Waals forces have to be overcome. Use of the data booklet is relevant to this question. The volume of sample of ammonia is measured at temperature 60 degrees centigrade and a pressure of 103 kilopascal. The volume measured at is 5.37 into 10 raised by 2 minus 3. What is the mass of the sample of ammonia gas? So again PV is equal to nRT. This is very simple. Again applying PV is equal to nRT, and PV is equal to mass over MR RT. So what mass of the sample of ammonia given? The mass is equal to PV M is equal to PV into MR over RT. So by applying this formula we can use pressure is 103 into 10 raised per 2, 103 kilopascal, it is measured in pascal, 00, and volume is 5.3 37 into 10 raised to minus 3. Mr is ammonia is gas, so 17 divided by 8.31 is the gas constant, and temperature was 60 plus 273. So by applying this, the M is equal to 3.4 gram. So next question is, which compound is only gas at RTP? So CH3, CH2, this is amine, 59 with Mr is 59, and hydrogen bonding is there, strong bonding is there, so it exists in gaseous state. Again propanol, also hydrogen due to hydrogenity exists in NMR is 60 liquid state. CH3, there are two alcohol group are attached, so this is definitely will be liquid. So only one option is left, that is CH3 CH2 Cl. So this is D. Question number 11, use of the data booklet is relevant to this question when 0.150 gram 15 gram of an organic compound is vaporized. It occupies a volume this centimeter cube, 405 Kelvin temperature, and 1 into 10 raised to 5 Newton meter inverse 2. Using the expression PV is equal to nRT, which of the following expression should be used to calculate the relative MR? We know MR is equal to PV is equal to nRT, and PV is equal to mass, and number of mole is equal to mass over MR RT, and P is equal to MR is equal to mass temperature gas constant temperature divided by PV, and 0.15 is M mass, R is 8.31 into 405 Kelvin divided by pressure is 1 into 10 raised to 5 into 65 centimeter cube, which is equal to 65 into 10 raised to minus 6. This should be expression. Now look at the option. This is 0.1 10 raised to minus 65. This is not correct. 0.15 mass gas constant and 405. This is correct, but this is incorrect because it is 10 raised to minus 3. 0.1565 volume. This expression is not correct. This both expression is, this is temperature and this is gas constant, while expression is MRT over PV. So these two expression are not valid. So D is 0.15 into 10 raised to into 8.31 into 0.5 Kelvin divided by 1.10 pressure, and this is volume. This is correct. This is correct. That's temperature, and this is gas constant. This is mass. So D option is correct. Which least resembles an ideal gas at room temperature and pressure? Ammonia least resembles an ideal gas. Helium, hydrogen, and methane. Ammonia is least resemble an ideal gas. Which diagram correctly describes the behavior of a fixed mass of an ideal gas? T is measured in Kelvin. So in first graph P is by decreasing pressure, pressure is decreasing, and at constant temperature we know that pressure is inversely proportional to 1 over V, and PV is equal to K. So for example, when we increase pressure, volume is over here. At zero pressure, volume is, this is not practically possible. This is not possible because higher pressure, at higher pressure volume cannot be zero, because higher pressure there will be some repulsive forces between the gas particles, that is due to the electrons. So over here repulsive forces start when molecules of gas come closer to each other. So this is incorrect. PV is equal to constant. We know that PV is equal to constant, and by increasing pressure, if pressure is this, PV is, so PV is equal to constant at constant temperature. At constant temperature PV, there will be a straight line. So this is not a straight line, so it is incorrect. So again PV versus V, by increasing PV is equal to constant at constant temperature. PV at constant temperature, volume, by increasing pressure, volume is not increased, volume is decreased. So this is also incorrect. So this is correct option, because by increasing temperature volume is decreased at constant pressure. So this graph is correct. Measured values of pressure, volume and temperature of a known mass of gaseous compounds are to be substituted into equation PV is equal to nRT in order to calculate the relative molecular mass MR of the compound. Which conditions in order to this is measured values of pressure, volume, temperature, known mass of gases. These are the graph for this question. And question number 14, in order to calculate the relative molecular mass MR of the compound, which conditions of pressure, temperature would give the most accurate value of MR? Mole is equal to which conditions? So this is in order to calculate the relative molecular mass of the compound, which conditions of pressure and temperature would give the most accurate value of MRs. This is according to the PV is equal to nRT for ideal gases, low pressure and high temperature. At low pressure and high temperature, these condition gives the accurate value of MR of the compound. So C option is correct. So this is all about of this class, this tutorial. Hope you will understand these questions.